In this video, we will cover the review exercise 3 at the end of tutorial 3 on pages 286 through 292 in the text. I highly recommend that you take a little time to first look over the drawing and read the instructions that follow, as these are the guidelines I will use to grade the assignment. At first glance, I see that this print has a radius and a diameter given, and a couple of angles, and then some fillets. So I'm going to start by creating the two circles that I can see, and then I notice that those flats seem to come in tangent to those sides of the protrusions, the 35-degree angles. So we'll develop a game plan from there. I'm going to begin by creating a circle center point. Here's the shortcut. The text instructs us to create this geometry at z minus 1. And also notice that we are in level 1 in terms of the working view. I have a diameter on the print of 1.75. And now it says to enter the center point. I hit enter and it gives me my diameter, then I place it on the center point. I'm going to apply that. Make sure it's down in the negative z, and it is. Fix my top view again. I'm still in the command, so I can just go to my parameters, z negative 1. The other circle is given in a radius off the origin, so I'm going to put in that radius of 1.5, hit enter, and now I'm prompted to place it in the center point, and those are my two circles. I think the next thing I can do to build anything would be to put in the angled lines, the 35-degree angled lines. So I'm going to check out of that operation, go to the shortcut, create line endpoint. This needs to be a negative z as well. It says specify the first endpoint. I'm going to start from the origin. And this is, remember, 0 degrees, 90. So I need one at 35 degrees off of the 90, which would put me at 55 degrees. So there's 55 degrees. When I hit enter, it'll place it, and then it just wants me to put an ending on it. Apply that. Specify the first endpoint. This is another one. Put the angle in. This time it will be 90 plus 35 at 125. Hit enter. And then we place the endpoint on that. I can go ahead and check out of that operation. Make sure they're both down on the 1 inch because I didn't remember if that held or not. Fix my top view. Now I can do a little bit of trim and extend. I just go to trim, break, and extend. Try divide. Yes, it works pretty well on that. There's many ways you can trim. Check out of the operation. Now I need to duplicate this geometry, or should I say replicate. So I've selected it, the two angled lines. I'm going to go to X-form, rotate. I'm going to copy it 2 times at an angle of 120. And I came up with that because a full circle is 360 degrees, and yet these are 3 protrusions evenly divided. Accept that. You can clear colors if we like. Now I have these protrusion sides that look to be tangent to the flats. So I'm going to create some splines at those tangent points. This basically create lined endpoint. I've got a flat this endpoint to that one, flat here, and a flat here. And those look good. I'll check out of that. Now I can trim some more. Go back to trim. Trim divide, which is right here, works really well on these. Take them out. And now I've got my flats. Check out of that operation. I can eliminate these tangent lines that we were using temporarily because I'm going to build the whole protrusion and rotate it going forward. So now I'm going to go to the isometric view, and we need to translate that protrusion geometry up a ½ inch. So I'm going to select the entities that are involved in it, which are these four. Xform, translate. I want to copy, one copy, a ½ inch positive in the Z, and that looks good. So here I'm going to, it looks like I need to do a lot of trimming, but some of that will be done when I put the radiuses in, the fillet radiuses. And it looks like I've got a 0.125 radius typical all around. So I'm going to clear colors. I'm going to create a fillet entities. This fillet is 0.125. We'll just start putting them in. This will help. This will also trim that circle out of there, the rest of it. Those are in. I can also put the 125 fillets all around everything. I think before I do that though, I'm going to check out of this operation and I'm going to delete these extra lines. They're no longer needed, just for clarity. Go back to create fillet entities 125. We have a fillet there, 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 and two more. And check out of that command. At this point, we are instructed on page 287 to create the 3 draft surfaces. So I'll go to Create, Surface, Draft. I'm going to start with the top one in the protrusion. So I'm going to use a partial chain on this one. I'm going to use the flat. And then it says select the last entity, and it's also that flat. I'll accept that. My length is only a ½ inch, and I've got a draft of 10, an angle. I haven't hit enter, that's why none of that is taken yet. My draft angle is backwards, so I just hit reverse and corrected that. I'm going to apply that. I'm going to do a whole chain one this time. Pick that chain. And the ½ inch is good, because if you look at section A of your print, this is where I'm deriving all of this information now. But there's no angle, so that's all I need to do and hit enter. And I've got that one. One more draft surface to create. It's a full chain. It's this chain. I want to pick it. ½ inch and no degrees. Looks good. I'm going to accept all of that. And then I can just go up to my shade to make sure everything looks good. So we've got our draft surfaces, but we need to put the edge curves on all of them. So I'm going to change colors so I can keep track of them for now. And I'm going to go to Create, Curve, curve on edge. And basically what you do here is select a surface as we're prompted. I select a surface with my regular click. Move arrow to desired edge of surface, so I free mouse up to the top and click that edge. Another surface. Make sure you don't forget the fillets, otherwise when you go to chain everything, there will be breaks in your chain. It'll drive you crazy. It's also part of the reason I change colors when I'm doing the edge surface, but so far it looks like I've got edges on all of those. Now I'll do the center. We're still in the command. There's an edge there. Now if I compress my middle mouse button, I can pivot. Pick that edge, free mouse up and click it. The fillets as well. Jumping over to these fillets. Be kind of organized when you're doing these so that you don't forget any and have to pay for it down the road. Fillet. I'm going to wheel in on that. I'm not sure I got that one. I may have slid off of it, which is why it didn't take. Doesn't matter which side you're on. Clear colors. And I just want to look over and make sure they all look like they're in there. Looks pretty good. And there we are, finished with page 287. Ready to go to page 288. It says we need to bring this arc up from the bottom up to the protrusion. I'm going to go back to the green because I'm going to build that surface in by first bringing that arc up. So I want to pick this arc, not the surface, which is that, but the arc. See it light up? Pick it, X-form, translate. I want to copy this because I need the one below it to anchor my surface to. You'll see when we do that, I'll point it out. We go Z positive 5, and there's the arc translated. Check out of that. Now I'm going to close the top chain with a fillet as per the instructions on page 288. Create fillet. This fillet is 0.0625 radius. There's going to be one there and there. And apply it. And check out of that command. Now we want to fill in that green surface using ruled or lofted surface. But I have to do a couple things in preparation first. The first one is to put edges on these surfaces so it doesn't try to overlap there. So I'm going to gamble and not change my colors on this. I want to create curve on edge. pick that edge, slide, free mouse to the edge, pick this edge, free mouse, and pick the edge. Enter or OK. The other thing we need to do now is to break these lines up here so I can start a new chain there. So I go up to Trim Break, Break at Intersection. It says Select Entities to Break. I want to break this line at this edge, and I want to break this line at this edge. Enter. I need to check these because it was a little bit obscure. All you have to do is hover over them and see they're separate now. So that was good. But it always pays to check them because they could drive you crazy. So at this point we can now fill in with our ruled surface. So I'm going to create surface, ruled or lofted. I've got a partial chain. It's going to start at this little piece of line. I'm going to reverse the direction. Now it says select the last entity. I'm going to pick the other little piece of line. Now I'm prompted to lofted surface define contour number 2. That was contour 1. I've got to twirl this thing around a little bit and get back here and pick. This time it's just the arc from the fillet and the other arc from the fillet. There is no contour 3, so I think we're closed in, and let's try it. Very good. Say OK. Clear colors if you need to. And we've got the surfaces. Back onto page 289. I'm going to an isometric and a fit. So now that we're going to do the flat boundary surfaces, this is a good idea to change colors here so that you can get some contrast, since we're going to do the flat boundaries as opposed to the drafts. So to create those surfaces we need good chains, and we're going to find out if we have good chains real soon. Create surface, flat boundary surface. We have our chain on. We'll pick that chain. That chain says there's a branch point reached and we need to select the next branch. That's not a big deal. It's a little confused because of this edge line we put in here. We probably had a solid chain before, but you need to get up close and pick that little piece. And when the arrows disappear, you've got your full chain. Isometric and fit, and we'll take that. And we can clear colors, and there's our chain. I checked out of the command accidentally. Let's go back into it. Create surface, flat boundary surface. Full chain is on. This is the chain of boundary 1. It says select chains for boundary 2. That's boundary 2. It looks like a good chain. There's no branches, and it says 3. So we've got 2 good chains there. If I just picked the 1, it would fill in the center. But since I picked the 2, it's going to fill in this area. And apply it and check out. So there are our flat boundary surfaces. And also, I was saying to be aware when you're picking your edges to make sure when you go here, create curve on edge. Not only, I reminded you not to forget the fillets because it'll mess up your chain for like what we just did. But the other thing is, make sure that you are going up inside up. See, if you're not close enough, you might catch the side, and then that would mess up your chain for the flat boundary. So I can just hit the escape button and get out of that, but I just wanted to remind you of all those different hurdles that I've run into. So now we can duplicate, or should I say replicate, those protrusions, because we need 3 of them. And now that it's a complete object, this is the most efficient time to do that. So I'm going to go to Xform, Rotate, and select entities to rotate. Just start picking this. At some point it'll realize it's one object. You don't have to pick every single line and every single surface. Well, once you see everything yellow, you can go End Selection or Enter. Then you tell it, I want 2 of these. I want copies, not move. And they are at 120 degrees apiece because I need 3. 3 times 360 degrees all the way around is 120 degrees. And then just clear colors, isometric, fit. And at this point we're ready to establish our stock. Okay, so to set up our stock, we need to work in a different level. That way we can turn the stock on and off for visual purposes. And to do that is the same as you did in tutorial 3. And you can see I had already practiced because they're already in here. And we just want, they're both showing, but I need to activate level 2 and check that. Now you look down here and level 2 is activated. The color doesn't matter, stock's always going to come in as red, but I'm going to pick a different color to blank out this hole. And on page 289, it asks you to create a flat boundary in that hole before you set up the stock, but I tried that and it seemed to affect my stock extruding, so I'm going to do that after I set up the stock for better luck. So I'm sorry, now that I've activated level 2, I'm ready to set up the stock geometry, and that is done by Solids, Extrude, Chain is on. Sometimes you may need to go back to your wireframe. I want to pick this chain. It looks good. I want to check it. I want to create a body. I want to, my arrow is right. I want to go up 1 inch. And I don't want to reverse direction. Check that. That looks good. I can solid it to make sure. Back to wireframe, we're going to put the hole in now. Apparently our stock's going to come with this hole already in it. It's going to be like a tube. So that's why they want us to blank it out later, because they don't want us to generate code for machining that hole. But first we have to extrude it into our stock. Solid, extrude, chain. I'm going to pick this chain right here. Select it. The direction is down, so I'm going to reverse it. I want to cut the body and extend by 1 inch. Check that. Solid. Now our hole's in there. But still, the machine's going to think it has to cut the hole. So we do need to go back and blank that out, just for the purpose of not generating code. Back to wireframe. Isometric and fit. I changed color here in anticipation of doing this, but I also need to, I'm down at the bottom now, draw that in level 1 because stock is not considered geometry and I need geometry. So go back to my levels, activate level 1. They can both show. Now we're back in the geometry creating level 1. I want to create a surface, flat boundary, and I want to create it in that middle circle right there. See how it formed? Check out of that command, shade it, fit, for isometric fit, and there's our stock with the hole blanked out. Again, I could go back and turn off level 2. See, right now level 1's active, but level 2 is still showing. I can turn it off by doing that. Now it's not showing or active. But we're going to need the stock when we get ready to set up a machine, so I think we're pretty much ready to do that. So after picking the default mill that we've been using all along, I need to set up the tool settings as usual. And this is number 6 and the same old settings we always use. For my stock setup, however, I need to go back and light that level 2 up. So I'm going to X out of that. I've got to go back to get the stock to show and also to make it active. We can leave the part geometry visible if we want. And check out of that. Now I can go in and set up my stock. So I'm going to pick a solid. I'm in the top view. This is my selection button. From the top view, I want to pick this whole solid stock extrusion, if you will. I can also put a display up wireframe on it just to make sure it took, and it did. The other thing we need to do, though, is we need to set up a stock model as part of this part. I know that's a little confusing, but it has to do with the fact that some of our geometric features are already captured within the stock itself, and we need to point that out. So we go through Toolpaths and stock model. Again, we're in the top view. And we'll name this one stock. Seems a little redundant, I know. But actually, this is one of the more realistic applications because you may be finishing something that's been cast and just putting in a few more geometric features. So a lot of your part geometry will be generated from your stock. So they need to make that connection. Okay, so we call it stock. It's going to be a model. And we're going to select it. We're in the top view. We have stock definition up here. So this is our select button. In the top view, we select that stock model. End selection or enter. And check out of there. And it should be good. It says you can alternate T to eliminate the stock model. But what they don't tell you is you need to turn off level 2 first for visibility. So I'm going to turn level 1 on, and I'm going to remove the visibility of level 2, and now it's disappeared. I'm also going to go back to my stock setup and turn off my display. You can leave it on if you want to. I prefer not to. And now we've got a stock model, so we're ready to start roughing out the part, and we are instructed to use Surface High-Speed Rest Mill. So I'm going to go to Toolpaths, Surface High-Speed, Rest Rough. This is really the name of my program, if you will, and it will actually show up in the verbiage with the code and everything else and all the other comments that you put in the program. I prefer that you put your name in here as well. That way I can see your name over here if I need to. The job's important, but the name's even more important. But anyway, this is the one that I use for my files. So there's the program name. And we are prompted now to select drive surfaces. I'm going to go here and use my quick mask button, quick mask drafting, surfaces on. I'm going to go to quick mask surfaces. pretty much highlighted the whole thing. I can end selection or hit enter, and I'm going to need some containment boundaries for this. I'm going to go in 2D chains. I'm going to flip this up. I'm going to pick this chain and this chain because I'm only working that one surface. Check out and check out. Okay, we know we are in rest roughing the tool. We need a 1/2 inch bowl end mill with a 0.0625 radius. Go to the library tools, 1/2 inch bowl end mill with a 0.063, which is just rounded number. Pick that. Here we're going to rough and that's pretty much it for tool holder. Cut parameters. Working on page 290, I'm looking at the instructions we are given. They ask for a maximum step down of 0.0375. Disable add cuts, which it already is, and corner rounding. Now we'll go to our step over percentages, 45%. That's of the cutter diameter, so a little less than half. Each time we step over, we go a little less than half the diameter of the cutter, which is pretty standard in machining. Stock to leave on walls and floors is 0.05 or 50 thousandths, and that's because we are doing a really rough deal here. We're just kind of hogging stock out, so we want to leave something for finishing. We don't want to take it all the way. The other thing it says is transitions, entry helix, which we have. The linking parameters took care of themselves, so we're ready to generate that toolpath, that code. Looks good so far. Let's see what it verifies like. Looks good. Okay. Now I want to do that surface finish blend to do the floors first. And in order to do those, that particular operation requires, I'm going to do an alternate T here, it requires some lines to blend along with a drive surface and a containment boundary. It also wants some blending lines. So we're instructed on page 291 to put some blending lines in. I'm going to switch to top view, fit, and I'm just going to, it says to use parallel lines, create line parallel. I've lit up this one just by hovering. It says here select a line, so I select a line. My distance per the text is 0.15. I'll hit enter there. Now it's saying indicate an offset direction, which will be over here. I want to apply it, and I want to put another one adjacent to it right here. Doesn't appear as though I have a line to select, however, so I'm going to make one. So check out of that operation. Zoom up on this a little bit. Go to create, curve, curve on edge. Here it says select a surface. I'm going to select that surface, free mouse up, and then pick that edge. Accept it and check out of that. Mouse wheel it back, tip it a little bit. Try my parallel line now. Create line parallel. Select a line. Select that line. Select a point to place the parallel line through. I'm going to pick an offset amount and hit enter. Indicate an offset direction, and it's right there. It's hard to see that line, but I knew it picked it because it gave me the next prompt. So we'll go ahead and fit that. Now we are asked to trim and extend the lines out. I'm going to wheel this up a little bit, bring it in. hit my scissors, select entity to trim and extend. I'm just going to pick the trim one entity at a time. You hover over this, it lights up. Select it, trim it to that line. Next one, select entity to trim and extend. Select this line, select this circle. Select this line, select this circle, and select this line and this line. Hey, it worked that time. Sometimes it gives me trouble and I have to just move things around a little bit and try it again. It's a little bit quirky that way. So we have our lines now for our blend, so we can go ahead and start putting in the operation, which is Toolpath, Surface Finish, Blend, and I'm going to pick my drive surface as this one, End Selection or Enter. I need a containment boundary, a check boundary, and I'll pick this one here, this circle, and then I End Selection, go back and pick something to blend to, which will be these lines. Blend, define chain 1 here, blend, define chain 2 here, and we're good. You can check out of all of that. We can pick a tool, which is our 1/4 inch ball end mill. Select library tool, 1/4 inch ball end mill. We can go ahead and take it. I've already used it and it remembers. Here we're going to finish the floors. And you can put anything you want in there, whatever appeals to you when you're trying to look through your program. The surface parameters are not to leave any stock on walls on the drive surface or the check surface, and that's going to prompt a warning for us about that later, you'll see. Finish blends parameters, we want a total tolerance of 1,000th and a maximum step over of 20 thousandths. And enable a long and a cutting method of zigzag, which are already in place. You can check out of that. Here's that warning I was telling you about. We'll just say OK to that. And we've got the operation. As you can see, even though we picked that entire drive surface, we only had the blend portion of it in one area, so it only generated for that one spot. We need to rotate that. So up here we'll go to Toolpaths, Transform. We need to pick Rotate. We only want this operation, the surface finish blend. Our high-speed rest mill was fine, and it covered all the way around. And when we rotate, personally, I tried 2 instances as per the text, but it only seems to work when I say 3 instances. The angle between, down here, this is our start angle. We want to start at 120. And then we want to have it at increments of 120 to make it around 3 of our 360 degrees. Check out of that. And let's run the job now. I'm going to pick everything. I just want to see the whole thing run. I'm going to go isometric, fit, pull it back up a little bit. You middle mouse wheel, you can activate that. And you can move this around while it's running as well. So that's our rough rest mill, our 2D, our high-speed milling, which is a different type of milling. Floor 1, floor 2, and floor 3. Okay. I'm not sure why it returned back to that containment boundary, but everything looks fine. So I'm going to keep it. Okay, so all we have left to do now is to finish the walls and the edges, basically pick out the corners as per instructed on page 292. I'm going to do an isometric and a fit. I'm going to go to Surface Finish, Toolpaths, Surface Finish, Contour to do these walls. Select Drive Surfaces is simply the entire QM surfaces. It knows what to do. I don't even have to use containment boundaries or anything here. And Selection, take it the way it is. It'll intuitively know what to do. I need the 1/4 inch ball end mill again. I'm going to put in Finish the Walls into my program. I want to put this clearance on. We won't be leaving any stock on the drive surface. We're going to use a total tolerance of 1/1000th of an inch and a maximum step down of 0.02. 0.02. And we're going to go into cut depth as well, absolute. A minimum cut depth of -0.02. Try to do a better job typing this time. And a maximum cut depth of -0.5. And those look good. And I think we fulfilled everything we were instructed to do. This is all on page 292. I'm just doing it as per I'm instructed. Instead of doing the whole job, I'm just going to verify this operation, which is already checked, just to take a look at it. Theoretically, all of that stock would be out of there anyway. And see, it's considering the outside of these walls, even though this is, say, a cast or some type of stock that's already captured it, just to make sure it's where it needs to be and that it can blend with this this fillet here. So that's correct, what it's done there. Then all that's left is to pick out the corners, basically by using the pencil toolpath. So Toolpath, Surface Finish Pencil, select Drive Surfaces. I'm going to pick everything, essentially, and end Selection. I don't need any containment boundaries, check boundaries, or anything like that. So I can just check straight out of that. I do need a tool though, 16-inch ball end mill. And here I'm going to pick out the corners. Go to surface parameters, and we're not leaving anything on the drive surface. We just need to set our pencil parameters. It calls for a total tolerance of 0.001. Numbers per side is 10. 10 with a step over of 10 thousandths, so 0, 1. Cutting method is zigzag. Allow negative and positive Z motion along the surface and a bitangency angle of 165 degrees. And that's our part. It's generating, that's why it's dirty still here, and it generated. I'm going to select all and run it one last time. There's our hogging out of the main stock. with the rest rough mill. Finish blending our floors. Get those out of the way. Now we're going to do the walls. All the way around on that draft surface. And just check and make sure everything's okay on the outside part of the stock as well. And then pick out our sharp corners with the tiny mill, because it's more efficient to do the main machining with the bigger one. And there's your part. So that's mill level 3, review exercise 3. Good luck.